Okay, when it comes to really graphing polynomial functions, we obviously want to be able to graph it, but there's a little more that goes into it. We need to be able to use a calculator to kind of really look get some really precise coordinate points of some important points on the polynomial. Use those to sort of describe what's happening with the polynomial. Let's look at an example here. This is, if you watch the previous video, what we did was we had the graph. We actually started with this graph, and then from that graph we generated this function, and it was not an insignificant thing that we did. Like, this function is disgusting. But when it comes to graphing polynomial functions, we'd be starting with the function and then wanting to get to the graph. That's typically how these questions are asked. Now, this looks very intimidating, but I know that if you've kind of seen the preceding videos, we talked about what a polynomial is, that this is something that you can manage. It might not seem like it, but it totally is. We can use the rational zeros theorem here. Now, there are a lot of factors of 1024, so there's a lot of possibilities for like the P over Q thing, like the possible rational zeros. However, if you look at the graph, like at the end of the day, they weren't going to be big numbers, so you would have been able to find them all relatively quickly, and you would have been able to handle this. The 1 over 256, don't even worry about that. That's just so that I could more easily show the entire graph in like a reasonably small like grid. Okay, so besides just being able to find out what the zeros are, which is kind of a very important point, a very important part of this, and the y-intercept, the other thing that we're often interested in when it comes to the polynomial is, where is it increasing? So what it means by increasing is all of this part. If we were to like look left to right, okay, this graph is increasing from the bottom left up until it gets to this maximum point. Then it starts decreasing. It's also increasing from that minimum point to that maximum point, and then from this minimum point all the way up forever. And so we want to be able to represent that region in interval notation. Okay, we also want to know, when is it decreasing? So right here it would be decreasing. In these areas where we go from a maximum to a minimum, we're going to be decreasing. And so we want to use interval notation to describe those areas. Now notice that it's going to be, in order to do that, it's going to be really important. We are going to have to know the coordinates of this point here. So know the coordinates of like this little relative maximum, we call that, this relative maximum here, and this relative minimum here. Okay, we know the relative minimum here. It's a 0 at -4. And so those points are also called, when it comes to a polynomial, they are also called turning points. Turning points. And really, like this turning from going up to going down, it's turning. From down to going up, it's turning, okay? And so that's what a turning point is. And we need to know coordinates of turning points, okay? That's pretty important, turning points. Okay, another thing that we're often asked to do is describe where on this graph, or where is this polynomial, where is it greater than 0? Meaning, where is it positive? So where is it above the x-axis? So this spot here, that place right there. Where is it above this is all above the x-axis there. It's above the x-axis here. And then where is it below the x-axis? So like, what are these sections in interval notation? And so we're going to be having to use interval notation a lot when it comes to doing this. And so the factored form of this polynomial, because we found that x plus 1 was a factor, and then we just factored the resulting, basically the quotient, quadratic. The factored form of the polynomial is just going to be, sorry, let me go back here. Oops, I don't know what happened. factored form of this polynomial is just going to be, I'm going to do this, and now I'm going to get it eventually here. Sorry, it's going to be x plus 1 times 2x minus 1 times x minus 2. Okay, and so that's great. Now we can use this information to find the x-intercept, because if x plus 1 is a factor, then that means that there is a 0 at the point negative 1 comma 0. There's an x-intercept at the point 1 half comma 0, and at the point 2 comma 0. So we can actually go and put those on there right now. We can say, all right, there's a 0 right there, there's a 0 right there, and there's a 0 right there. Okay, and we also know, right, that there's a y-intercept at 0 comma 2, so right there. Okay, now the issue is that we have everything we really need here, but we don't have the precise locations of those turning points. And so what we can do is go and look at a calculator in order to figure that part out. Okay, so we can now plug this into a calculator. Okay, so if we turn this calculator on, we go to y equals. This doesn't seem to be working. Hold on a second. Okay, we turn this calculator on. We go to y equals, and now we type that function in. We go to graph, and there it is, graphed. Now we can find the location of these turning points, and the way we do that is hit second the trace button, and we're going to find a maximum, right? We're going to find a maximum. So we're going to go down to 4, hit enter, and we've got, asking us to flick a point to the left of the point that it's given here. So if we pick a point to the left, that means we're going to go over to the left. So this is definitely to the left of that maximum. I went too far. Okay, and now we can go to the right. We're going to pick a point to the right of that maximum. So like over here is definitely to the right. And then it wants us to guess, so we're just going to hit enter again and guess there. And it gives us this point where the x value is negative 0.366 and the y value is 2.598. So we're going to write that coordinate point down. Then we're going to do the same thing, but now we're going to find, we're going to hit second calc, and we're going to find now a minimum. Okay, so we're going to say, all right, guess somewhere to the left. Guess somewhere to the left of that minimum, where it kind of drops down below the x-axis there. So somewhere in this area, let's keep going. It's very slow to respond here for some reason. Okay, so let's guess right there. Now notice it puts in a little arrow. If I go to the right more, guess somewhere to the right of the minimum, like there, and then I want to guess, I'll just hit enter again. And it's saying, okay, the lowest possible point between those two arrows is this coordinate, 1.3660278 and negative 2.598. So we can write that point down, and we can go and transfer it onto our graph in a minute. Another way to do this without a calculator, and the calculator is probably going to be more available to you on something like an AP test or more of the standardized test than Desmos would be, but Desmos makes this really easy. I just type in the function, I click on the graph itself, and then boom, there's one of the coordinate points, and there's the other one, and we could just transfer those onto our actual graph as well. So let's go back to the actual graph then. Sorry, too far again. Alright, so we had the points. We had these points. We had negative 0.366 and 2.598. So negative 0.366 and 2.598, so somewhere like right here. And we also had 1.36 and negative 2.598. So 1.366 and negative 2.598, so somewhere in this area. And so what that tells me then, now that I have those points, is I can draw this graph in. and it would go down from the bottom left. Okay, it would go up. It would, what happened to that point I had? It would go up and hit that point that somehow got erased. Come back down, hit that point, and then go back up and do that. So that's like what the graph of this function would look like. And I know, since I know that those points, let me just write them back in. This point here was negative 0.366 and 2.598, and this point here was 1.316 and 2.598 negative. Then I can answer the remaining questions here. So the first part here is, when is f of x greater than 0? So in other words, what is this part here, right there, and this part right here? How do I write that in interval notation? Well, it's pretty easy. All we need to do is say, all right, we go left from right. It started being greater than 0 at that x-intercept right there, and that x-intercept was 1, negative 1. So it is greater than 0 everywhere from negative 1, not including the negative 1, because it is 0 at negative 1, until the next 0, which is 1/2, not including the 1/2. So 1/2 union, and then we pick back up at the last 0, which was 2, and then it goes forever. So that is when f of x is greater than 0. f of x is less than 0 at the other spots. So that's everywhere from negative infinity to that other 0, that first 0, negative 1. Okay, and then it goes back below the x-axis right here, right? It goes back below the x-axis right there, so that's 1/2 to 2. Okay, so that's when f of x is less than 0. Okay, when is f of x increasing? Remember that increasing meant everywhere where we've got it's going up, like as we're going up. Right, so right there and right there, that's increasing. Okay, so how do we say that in interval notation? Well, that would be everywhere from, let me go back to a pen, everywhere from negative infinity up until the x-coordinate of this maximum right here, which is negative 0.366. Then union, it starts to increase again at 1.316, and then keeps going forever. Okay, so it's increasing on that and those areas. Then the opposite of those areas and the part of the domain, the opposite of that part of the domain would be where it's decreasing. So everywhere from that first x-coordinate of that turning point, not including it, not including it, to the x-coordinate of the next point, 1.316, and that's it. Everywhere else it's increasing. So there we answered all of these questions and graphed that polynomial.